Cool. First question A. Given a linear system AX for B where A is a matrix and diagonally dominant, if L transpose 3, negative 2, 1, 0 for negative 1, 0, 0, 5, then find A, matrix A. First, we have to determine matrix L, which is L is 3, 0, 0, negative 2, 4, 0, 1, negative 1, 5. Then we have to calculate A by multiplying L and L transpose. We just use our calculator to solve it, and then we get the final answer 9, negative 6, 3, negative 6, 20, negative 6, 3, negative 6, 27. Question B. Solve the linear system AX equal to 39, negative 22, 87 transpose. From above solution, we got A, and we declare X has 39, negative 22, 87. Then we put it in a matrix form. To find X, we have to use formula where X equal to negative A inverse multiplied by B. By using calculator, we can get the final answer, which is 4, 1, and 3. That negative x1 is 4, x2 is 1, x3 is 3.
Hello, so now we will solve the equation 9a. So this is the given equation, and we have to solve using the Thomas method, which I choose Thomas algorithm method. And we have to transform this equation into the matrix form, and the matrix form should be in the arrangement of like this, which D1 is here, D2, D3, and here C2, C3 and 0, and here is E1 and E2. Sorry, E2 and 0. So we have to make sure that the 0 component is over here, and then when it is matched, and then we can proceed to the next step, which we can count out with the table, which I here is representing the iteration of the matrix. So look at here, we have 1, 2, and 3 column, means we have 3 iterations. So we can immediately insert the value of D1, Di, the value of E, C, and B based on the matrix that we have formed previously. So here for the Di, we know here is the D1, this is the D2, and this is the D3. Thus the value of Di come out like 4, 4, and 4. So for the value of Ei, here is the E1 and the E2. So we have put negative 1 and negative 1. And for the E3, we just put a dash since we have no E3 in this case. Same goes to the C, C2, and C3, like what we put here. So we don't have a component of E1, so we just put a dash. And also for the B, this is the B1, B2, and B3. So after we have all the value of D, E, C, and B, we can calculate the value of alpha using the formula of alpha I equals to Di minus Ci times beta I minus 1. So this is the formula of alpha here. So for the alpha 1, it's given that alpha 1 usually equals to the value of D1, like this. So as the value of D1 is 4, so we can directly put alpha 1 equals to 4. And this is the latest value of alpha 1. And then we calculate our alpha 2 using the formula D2, which our D2 is 4, and our C2 is now negative 1, and our beta 1, we don't have any value of beta 1, so we have to calculate the beta 1. So the formula of beta is beta I equals to Ei over alpha I. So as we want to use the value of beta 1, and then we find the value of beta 1 using the value of alpha 1 that we have previously, which is 4. So from here, we get the beta 1 as negative 1 over 4. So we put the value inside the formula, negative 1 over 4, and we get this, 15 over 4. So we put here, 15 over 4. Same goes for the alpha 2. We will use the latest information of each component. So next, if you already finished this part, basically when we done the alpha part, then we also will done the beta part, because in the formula, we need to use the beta value to get our alpha. So after that, after we get our beta and alpha, then we have to find the value of W. So the formula of the W is Wi equals to beta I minus Ci times Wi minus 1 over alpha I. So here is the formula to find our W value. So here, for the value of W1, since C1, we don't have any value of C1, so we can assume as a 0. And then we just come out with B1 over Bi over alpha I. And then for the B1, the value of B1 is 3, and the value of alpha 1 is 4. So we can just write as 3 over 4. And then for the, same goes to the W2 and also the W3, just using the formula. And then after we get the value of the value of W, we go to the last part, which is we find the X. So the value of, for the W3, the value of W3 will always the latest of the w value, the latest iteration of the w, in this case is 3, will always equals to the x3. So basically we just can directly put the value like this. So here is 1, and we use the backward substitution method, which to find the next value. So for the x, this is the formula, which is xi equals to wi minus beta I xi plus 3. So here is the formula for the x. Alright. So for the x2, we use the wi value, which is w2 is 11 over 15. We get it from here, 11 over 15, minus negative 4 over 15 times 1. We times 1 because the value of x3 we already have here, 1. So the answer is 1. So we just directly put 1. Same goes to the next part, which is the x1. So when we already get the value of x, so this is our final answer, which is 1, 1, 1. So that's all for the equation for the question A. So for the question 9b, this is the given equation from the questions, and then we transform it into the matrix form, which also we have to arrange in the form of like this: d1, d2, d3, and d4. So here is our c2, c3, c4 is 0, 0, 0. So this is e1, e2, e3, 0, 0, 0. So the arrangement, this part should be, make sure the 0 is diagonally over here, and we can see it's already arranged in that form. So we can proceed to the next part, which is to the table of the Thomas algorithm. So here it's just the same. The iteration is 1, iteration 2, 3, and 4, because we have 4 columns here. And then we just need to insert the value of D, E, C, and B based on the matrix that we have done. So here is 4, 4, 5, 1, 4, 4, 5, 1, and 3, 2, 6 for the C, 3, 2, 6. So we don't have any C1 components, so we just put S dash. Same goes to the E. We don't have any E4 components, so we've put S a dash. And the BI, we have 10, 22, 3, negative 44. So we already put in the table. And then we have to find the value of D, and the value of alpha. So the value of alpha, basically we know alpha 1 will always equals to D1. So we just can directly put the value of D1 here and alpha 1 as a 4. And then we find the value of alpha 2 using this formula, which is, we will get the D1 as 4 minus 3 times 0.5. So the value of here, the beta I minus 1, we don't have the value of beta, so we have to find the value first using the formula beta equals to E over alpha. So for the beta 1, we can get 0.5 as the E value of 2 over 4. So we get 0.5, and we can put the value of 0.5 into the formula, and then we end up with getting 2.5 for the alpha 2. Same goes to the next iteration for the alpha 3 and alpha 4. We have to find the value of beta first, and then we're going to insert the value of beta into the formula. So when we already get the value of alpha and beta, then we can proceed to the next part, which is finding the value of W. So the formula of W is given like this. And we have, in this case, for the W1, we have to use the value of we have to use the value of C1. So here, we don't have any C1 component, which we can represent as a 0. Thus, we just, for the alpha 1, we can put the formula like, not alpha 1, W1 is B1 over alpha 1. So where we get 10 over 4, which end up getting 2.5. So the next W, we can find it using the normal equation, since we have all the components now, and use the latest information of each component. So basically like this, it's a B1, for the W2, we use the value of B2, which is 22, minus C2, which our C2 is now 3, and the value of W, I minus 1, which this is I is 2, minus 1 is 1, so the W1 is 2.5, so we insert the value of 2.5 in here, and over 2.5, which alpha 2 is also 2.5 here. So we end up getting 5.8. Same goes to the next iteration. When we finish finding the W, then we have to find the last part, which is the X. So the X, like what I said just now, the final value of W, any iteration of W, the final iteration will always equal to the final iteration of the X. So when we have the final is 3, so 3. In this case, we have the last iteration of W is a W4. So the the value of W4 will equals to the X4. So in here, look at this. You just transfer the value of W4 negative 26 to this. Also the same, negative 26. In this part, we will start using the method of backward substitution. So for the formula of x, we have this given formula. Why we use the backward substitution? Because here we have to use the bigger value, the bigger iteration of the x. So for the x3, example for the x3, we have to find the value using this formula, which wi, so w3 equals to negative 43 over 29, minus beta 3, which beta 3 is 5 over 29, times negative 26, which is x iteration plus 1, which is 3 plus 1 equals to 4, and this is our x4. So end up we calculate this, we get in 3. So the value is 3. Same goes to the next iteration, which is x2 and also the x1. If you already get the answer, so the final answer shall be like this: negative 1, 7, 3, and 26. Same with this one. Thank you.